you so much. I think we are ready for our next presentation, which is again very interesting topic that we are going to listen. That is improvement of the hydrophobic and mechanical properties of epoxy hybrid composite based on palm felt by the use of functionalized graphene oxide. Very interesting topic. Marya Raji, and the floor is yours. Welcome. Thank you. I think the same problem has occurred. I had. If you go to right click on the screen and Dr. Midani, you help me to solve this problem. Okay, yeah, great. Right, if you could unmute, please.
Thank you, sir. Hello, everyone. So my name is Raji Marya. I'm a researcher in Composite Nanocomposite Center. Sorry. I'm a researcher in Composite Nanocomposite. In Composite Nanocomposite Center in MAScIR Foundation from Morocco. My brief presentation is titled The Improvement of the Hydrophobic and Mechanical Properties of Epoxy Hybrid Composite based on palm felt by the use of functionalized graphene. I don't know what is the problem here. It's good now. It's good now. So wood as a natural origin raw material, wool, ecologic and renewable becomes more popular not only in structural application or to furniture production as a fuel, but also use it in auto industry to create free-form shape such as dashboard, rear parcel shelf, and inner door, etc. This application necessitates some characteristic as like low density, low cost, fast curing, that's making the fiberboard panel the most widely used wood-based material in the furniture industry. So fiberboard is a type of engineered wood product that is made out of glowed wood fiber as like particle board, medium density fiberboard, oriented strand board. The major difference in the performance of structural panel compared to the solid wood is the greaser thickness swell that occur when the panel are exposed to relative humidity and or direct contact with water. That is due to the higher pressure required to consolidate the panel mat. Also, the issue of brittleness and friability of the fiberboard has been a topic of interest for many researchers. Besides finding new sources of fiber in order to environmentally sustainable production of fiberboard. So the objective of this work is to remedy this problem via the investigation of hydrophobic surface modification of Dutch palm fiber felt extracted from Dutch palm leaves as a renewable biomass of fiber and the overall properties of the prepared fiberboard. So, the use of palm leaves was hand carded to produce palm fiber felts, and then were used to produce the fiberboard composite by compression molding process with epoxy resin bender at 0.5 white fraction % of graphene oxide nanosheet with and without chemical modification. And we can say that this process was made under the temperature, which is 150 degrees Celsius for 20 minutes. For the synthesis of graphene oxide nanosheet was prepared by the vigorous oxidation of graphite powder according to the Humer method in 2 steps, include intercalation process and exfoliation by sonication. for the functionalization of the graphene oxide surface, the 3-ethoxy-octyl-silane coupling agent as a long chain grafted silane molecule was added to the graphene oxide colloidal solution and heated under mechanical stirring for 2 hours at a temperature of 70 degrees Celsius. Therefore, the prepared graphene oxide and the functionalized one was washed and dispersed in the ethanol solvents. The prepared composite was characterized by chemical composition, statistical analysis, acoustic testing, mechanical and hydrophobic tests. So before the extraction of the palm fiber from that palm leaves, we have made a chemical composition of grounded fiber in order to have an idea about the state of cellulose fiber inside of our palm leaves, and to successfully choose the suitable palm leaves to produce a long fiber with the higher properties. As you see in the table, the results show that the chemical composition showed the amount of cellulose is around of 50%. However, the presence of the microorganism and the aging of the leaves during storage, as you see on the figures, may negatively impact the length of fibers. Also, for green fibers, the presence of water, high amount of water, of course, may also impact negatively the bleaching process. So, based on this, the results, our dried palm leaves has been used in this work to produce palm fiber felts. So here, the diffraction patterns of graphene oxide show the absence of any ordered crystalline structure as compared to graphite 1, which confirmed the successful synthesis of graphene oxide. Here, the FTIR spectrum of graphene and functionalized graphene oxide comparison confirmed the successful modification of graphene oxide through the apparition of 3 bands between 2900 and 2800 wave number that are attributed to the CH3 chain vibration of sp3, sp2, and sp1. This group is related to the alkylated group in the silane molecules. So here we have the sound absorption measurement, which is performed according to ISTM E90 standard at a tube frequency 150 and 1500 and 2000 Hertz. The test sound absorption coefficient of the tested sound absorption coefficient of fiberboard composites are presented in this figure as a function of composites and frequencies. So as you see, the results show that the presence of the graphene nanosheet will increase the sound absorption coefficient, which is due to the presence of void between particles and fiber, as well as at a high frequency, the fiber board has a slightly superior acoustic absorption ability. We can compared to low frequencies, there's a result showed for the such 3 composites confirm that the acoustic absorption mechanism is very complicated to the complex microstructure of natural fiber. So as you see, the mechanism illustrated in this figure show that there is 3 phenomena that may enhance the acoustic properties of our fiberboard panels, which include a viscous resistance between the air among fiber as well as inside of lemon and fiber sell well. The thermal exchange between a neighboring particle and finally elementary fiber and microfiber vibration friction between elementary fiber as well as microfiber sublier interfacial friction. So the mechanical properties of the composites are characterized by subjecting fiberboard with the modified and unmodified graphene oxide reinforced composite under 3-point bending load, as you see in this figure. This figure show the bending strength and the bending modulus of the prepared composite, which is present that the incorporation of graphene into fiberboard composites exhibit significant improvement of flexure strength and modulus attributed to the well-dispersed rigid particle. And then the incorporation of modified graphene oxide showed a slight decrease in the bending modulus because of the rubber character of a long chain grafted on the of course graphene oxide surface. However, this modification play a great role in enhancing the interaction between the matrix via enhancing the chain entanglement, leading to facilitate of course the strain transfer between matrix fiber and fiber graphene particles. So in order to improve the resistance of prepared fiberboard to water penetration, making them less susceptible to changing their dimensional properties, that can be decreased by decreasing swell proofing of fiberboard panel via enhancing the hydrophobicity of prepared fiber. So in this work, the use of functionalized graphene by the use of long chain grafted cell and molecule was used in order to enhance the hydrophobicity of our work. This figure shows a typical image of a water drop on the composite, and as you see, the palm leaves, which is in figure A, are in general hydrophilic with an angle contact of 59 degrees. For the combination of palm fiber and epoxy bender as a reference, the fiberboard panel was shown a contact angle value of 133 degrees due to the rigorous surface of the composites, of course. However, the decrease in angle contact, which is shown in figure C in the left, of course, depend on the hydrophilic oxygen contained functionalized group on the graphene oxide surface. So the addition of functionalized graphene oxide led to increase the water contact angle value to 153 degrees Celsius. I say degrees Celsius, it's just degree. That can be explained by the hydrophobic alkyl chain of silicon molecule grafted on the graphene oxide, and then by the high amount of functionalized graphene oxide nanosheets in the palm fiber board composites. Finally, it can be concluded that our fiberboard panel, based on modified palm fiber felt with functionalized graphene oxide, has been successfully produced using a hot press manufacturing process and epoxy resin bender. The soundproofing of our material has been enhanced with the incorporation of modified graphene oxide. However, the mechanical properties of our epoxy hybrid composites are very close to that of neat epoxy palm fiber felt composites. So enhancing the hydrophobic phobicity of the fiberboard panel may be a great way to minimize the water swelling damage via decreasing the water droplets stack on the surface due to the gained higher surface tension via the incorporation of modified graphene oxide in the panel. Thank you. I want to thank my teamwork, especially Professor Qais Abul Qasim and Mr. Rashid Bouhfid, and also the team, the organizer team of the second World Conference on the byproducts of palm and their applications.